Next chemical property, reaction with nitration mixture. What is the nitration mixture? Concentration H2SO4 and concentrated HNO2. So I'm taking that glycerol. I'm doing reaction with nitric mixture. So I'm taking here concentrated H2SO4 and concentrated HNO2. So from this mixture, what is the nucleophile electrophile which is coming out? From that reagent, which one is coming out? From that reagent, which one is gives? So from this reagent, it's going to be NO2 plus is going to be come out. Means from that reagent, an electrophile is going to be come out. Electrophile is coming out means from that reactant, electrophile can be replaced an electrophile. Positive charge can be replaced by a positive charge. So what will be the positive charge will be here? H. So those hydrogens are going to be replaced by nitro group. O, NO2, and this one is H, NO2, and this one is CH2, O, NO2. Glyceryl trinitrite. The formula is name is glyceryl trinitrite. Next reaction with acetic acid or acid chloride. Reaction with acetic acid or acid chloride. So reaction with acetic acid or acetic chloride and taking the glycerol CH2 OH and CH and CH2 OH. I have taken glycerol. I am reacting with acetic acid. What is the formula of acetic acid? CH3 COOH. I have written. Right now, OR I'm taking acid chloride also. ClO C double bond O. Sorry. C double bond O CH3. Acid chloride. So I have taken these two reagents and I'm reacting with glycerol. So acid we are taken. If we are taken acid means acid only is going to be releases H plus ion. So alcohols are going to be act as base. Alcohols can be act as base as well as acids. So if it is an acid means it is going to be releases OH minus ion. So water molecule is going to be loose. What is the remaining part? CH2 O C double bond O CH3 remaining as usual OH and CH2 OH. So we can call this one is monoestate. How many estate groups are going to be formed in a molecule? Only one we can call as monoacetate. I have taken one more, means one more acetic acid or one more acid halide. Same process is going to be repeated. It's going to be taking place of OH minus ion here from H plus ion from acid. It is going to be form CH2. Same process is going to be taking place. Again, loss of water will be takes place. This one is CH2O, CW1O, CH3. Now CHO, CW1O, CH3 and CHO, CW1O, CH3. So here 3 moles will be formed. Triacetate we can call. Triacetate glycerol. If you are taken that acid halides also same product only we are going to be get. If you are seeing here, it is acid chloride. If it is Cl is releases, it is going to be releases H plus. So what is going to be coming out here minus HCl in this process minus H2O. Minus HCl is coming out from that means what happened here? Cl H is comes out. Next remaining thing is CH2O CO CH3. CH2O CO CH3. Same product. If you are reacting with acetic acid, if you are reacting with acid halide, both are gives the same product. Next one is reaction with oxalic acid. What is the formula of oxalic acid? Hmm? Formula of oxalic acid. Oxalic acid formula. Carboxylic acid. Only COOH is there. C. Correct only, yeah? That only oxalic acid. Oxalic acid formula is or not? This is only oxalic formula, oxalic acid formula. Again, we are reacting with acid at 383 Kelvin. I'm giving the heat and I'm reacting with oxalic acid and glycerol. Acid we are reacting means what happened? Again, it's going to be taking place of loss of water. It forms CH2O, C double bond O, C OOH. Remaining is CHOH. This one is CH2OH. We can call this one as glycerol oxalate. Glycerol oxalate we can call. Why? Because this one is if it is really release H place, what will be the remaining thing? COO minus will be present. So we can call this negative charge is 8 oxalate. Now if I reacting with 1 mole of oxalic acid, what is the formal product is glycerol oxalate. I am reacting 1 mole of oxalic acid. COOH and COOH. Again, it's going to be taking loss of water. One minute. So I am heating that solution. What is the formula here? Glycerol oxalate. It is going to be taking place of loss of CO2 molecule. It is going to be loss of CO2 molecule. What is the remaining thing is forms? CH2O, C double bond O, H, and this one is CHOH, and this one is CH2OH. After the formation of this one is I'm going to be do hydrolysis. I'm doing hydrolysis. Where the hydrolysis process is going to be takes place. It's going to be break here. We can add OH, add hydrogen. What will form? So what is the product? CH2, OH, and CH2. Sorry, CHOH. Next one is CH2OH. Remaining product is HCOO. H HCOOCH. So what is this one? What is the name of this one? Formic acid. If you are reacting oxalic acid with glycerol in excess amount, it is going to be form the formic acid. It is going to be form formic acid. This is the our main product if you are taking the excess amount of oxalic acid with the glycerol. What happened if you are reacting oxalic acid with glycerol in increasing of temperature? Now we are reacting with at 383 Kelvin. I am taking glycerol with oxalic acid with high temperature, nearly 583 Kelvin. COO H COO H heating under 583 Kelvin. I am increasing the temperature. What will happen? It is going to be taking loss of water, but it is going to be taking 2 moles of loss of water is going to be takes place. But here at 383 Kelvin is going to be taking place of only 1 mole of loss of water. But here increasing the temperature is going to be taking loss of water by 2 moles. This is 1 mole and this one is 1 mole. So what will be formed here? CH2, CH, CH2. These are the same. CH2, CH and CH. So here what will be there? CH2, O, O, C. O, O, C. This one is C, O, O, CH. Remaining part is same. OH. Now it is undergoing on loss of CO2. Loss of 2 moles of CO2. Here it is 1 mole and it is 1 mole. What will form? This bond is going to be move to this side. It forms CH2 double bond CH and CH2 OH. What is the name of this one is? Allyl alcohol is going to be formed. If you have taken that oxalic acid and glycerol at 583 Kelvin, on heating it is going to be loss of 2 moles of CO2. It forms allyl alcohol. If you are taking that 383 Kelvin, it is going to form which one? Formic acid is going to be formed if oxalic acid is excess amount. Dehydration of glycerol. Dehydration of glycerol. What is the meaning of dehydration? Removal of water. Now I need to remove the water molecule from glycerol. What I need to add? What I need to add? I need to remove the water molecule from this one. So I need to add any H plus donor. If it is donating H plus, that is going to be attacking here. It's going to form water molecule. It's going to be losses. What are the reagents means? Concentrated HNO3, concentrated H2SO4, and potassium hydrogen sulfate. Potassium hydrogen sulfate. The reagent is KHSO4. Means in the place of H2SO4, one hydrogen is replaced by potassium. It is also can be released H plus. It is also can act as dehydration agent. I am taking glycerol COH. Here hydrogen is there, and here also hydrogen CH2. This one is H, and here OH. It will be OH and H. It is 1 molar. This is what? Glycerol only. Glycerol I have taken. I am reacting with potassium hydrogen sulfate under 623 Kelvin. So what's happened? It's going to be taking place of loss of water. 2 moles of loss of water is going to be takes place. It's going to form CH2 double bond CH. It will be CH2 OH. Allyl alcohol is going to be formed. So what is the phenols? Alcoholic part is completed. Next one is phenols. What is the meaning of phenol? Any OH group is going to be attached to aromatic ring or benzene ring. Directly attached to benzene ring. If it is not directly attached to benzene means what will happen? Benzyl alcohol, any hydrocarbon alcohol is going to be called. Not it is a phenol. Phenol means it is compulsory, it is directly attached to any aromatic compound. Now, the OH group is directly attached to aromatic ring are known as phenols. So simple example of phenol only, right? Hmm? Hydroxybenzene, hydroxybenzene, or this one we can call as a phenol. We can find this phenol in human urine in the small traces. It will be present in human urine in the small traces of phenol. It is introduced by run. It is introduced by run. Now, how can you classify these phenols? Only one phenol is there. There is a different type of phenols are there. Different types of phenols are there. So we can classify these phenols on the basis of number of hydroxyl groups present on the benzene ring or aromatic ring. If it is presence of one hydroxyl group, that is called as monohydric. If it is hydrocarbon alcohol, here phenol ring is here if you are taken monohydric phenol, dihydric phenol, trihydric phenol. Dihydric phenol means two hydroxyl groups present on the molecule. So the phenols can be classified into three types or many types. The types of phenols on the basis of number of hydroxyl groups present in a molecule. Present in a molecule. If it is having only one hydroxyl group in a molecule, we can call monohydric phenol. Monohydric phenol. Example, can we take this one? Can we take this one? Right? Shall I take OH meta position CH3? Shall I take OH and CH3 on para position? What is the name of this one? Phenol or the hydroxy benzene. What about this one? Orthomethyl phenol. Orthomethyl phenol. What is the common name? Ortho position. It is having CH3. We can call this one is cresol. On benzene ring, CH3 and OH group it is there. That one we can call as common name is cresol. It is ortho position to each other. We can call ortho cresol. So now it is meta to each other. This one is metacresol. This one is paracresol. So these are examples of monohydric. Now dihydric phenols. Dihydric phenol examples means there is a presence of two hydroxyl groups, one OH group present. This one is two OH groups present. So two hydroxyl groups will be present. I am taking here two adjacent positions. It is available. It is existed. I am taking two are the meta positions. I am taking one para positions. So what is the name of this one is on the benzene ring, if two hydroxyl groups on the adjacent positions, we can call as catcall. We can call catcall or as orthohydroxyphenol. This one is hydroxy. Which position? Now if you are taken, this one is phenol. To this phenol, one OH is attached to ortho position. Orthohydroxyphenol. Or our IUPAC name, what you can write? If you are taken, this one is benzene ring. 1, 2, 3, 4, 5, 6. Benzene. 1, comma 2 dihydroxy. Benzene also we can write. So common name is catcall. If it is meta to each other, we can call as resorcinol. 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 If it is para to each other, we can call phenol. If it is para to each other, we can call as phenol. So those are dihydric phenols. What about trihydric phenols? Trihydric phenols. So means there is a presence of how many hydroxyl groups? Three OH groups need to be present on molecule. Examples what we can take. I am taking three OH groups on adjacent positions. I am taking three OH groups on alternative positions. I am taking three OH groups on two are adjacent, one is alternative. Is this molecules are exist? Is there any type of these molecules? Is there? What are the names? 1, comma 2, comma 3. Try hydroxybenzene. Hydroxyl are there now. Hydroxybenzene. These are substitutions only. These are not functional groups. Why? Because these are not going to be involving in the chain. Now, if you are taking the common name is pyrogallol. Pyrogallol is the common name of three adjacent positions of hydroxyl groups on benzene. Now, this one is chloroglycinol. Chloroglycinol. So the next one is if you have taken this one is phenol. To the phenol, I'm adding one hydroxyl group extra. What we can write? Orthohydroxy phenol. Orthohydroxy phenol. So that is the common name of this one. If you want to write IUPAC name, 1, 2, 3, 4. 1, comma 2, comma 4, comma trihydroxybenzene. What is the picric acid formula? Picric acid. Picric acid. Alternative NO2 groups on phenol. On phenol, alternative NO2 groups are there. Then we can call as picric acid. Picric acid. What is the name of this one? I already given in alcohols and alcohols. What is the name of that two molecules? Benzyl. This one is benzaldehyde. OH group is there now. Hmm. Benzaldehyde. This one is benzaldehyde. Okay. This one is benzaldehyde. What about that OH? Hmm? Hydroxy means where it is present. Two. 2-hydroxybenzene or ortho-hydroxybenzaldehyde, not benzene. 2-hydroxybenzaldehyde or ortho-hydroxybenzaldehyde. We can call one more common name. We can call one more common name is salicylaldehyde. Salicylaldehyde or ortho-hydroxybenzene. Sorry, benzaldehyde. Ortho-hydroxybenzaldehyde. What about this one? Here, ortho 2, COOH is there. We can call this is aldehyde group is present, salicylaldehyde. This one is salicylic acid. Salicylic acid. Like that, you can take NH2, NO2, any one of the group on benzene ring with compulsory presence of OH. That is only called phenol. With presence of OH benzene ring, we can call as phenol. With that, you can take any group present on the benzene. We can call that one is phenol.